On August 10th of 2025, Russian commanders gathered in a secret underground bunker in Kersan, Ukraine. The meeting, held at 3:25 p.m., focused on planning a new military deployment in the region. Hidden beneath layers of concrete, the bunker was deemed secure by Russian high-ranking officials. Unbeknownst to them, Ukrainian intelligence had been monitoring the facility for several months. Antenna clusters on the surface revealed the bunker's location to Ukrainian surveillance teams. Supply routes and service entries were meticulously mapped using satellite imagery and drones. Inside, 25 Russian officers, including a battalion commander, discussed critical frontline strategies. Meanwhile, a single F-16 prepared for takeoff from a mobile runway in Ukrainian territory. The aircraft was armed with two 454-kilogram JDAM ER bombs for a precision strike. Ukrainian planners identified the bunker's ventilation shaft as the primary target for destruction. The mission relied on months of intelligence, pinpointing the exact time of the meeting. Russian commanders, confident in their bunker's secrecy, remained unaware of the impending attack. Ukraine's Air Force crafted a daring low-altitude flight plan to evade Russian radar systems. The F-16's mission was to deliver a devastating blow to the Russian command structure. This operation would showcase Ukraine's precision and tactical evolution in modern warfare. Ukrainian intelligence tracked the bunker's communication hubs using advanced signal analysis techniques. Satellite imagery confirmed the presence of vehicles and personnel at the bunker's entrance. The F-16's mobile runway, a temporary airstrip, was set up in a remote location. Two GBU-62 JDAM ER bombs were mounted on the aircraft's wing stations. A delayed fuse was installed in each bomb to penetrate the bunker's reinforced structure. Chaff pods and an AL-50 tow decoy were attached to counter Russian air defenses. Two 370-gallon external fuel tanks extended the F-16's range for the mission. The ANALR-56 SIM threat warning receiver was integrated to detect radar illumination. Mission software loaded WGS-84 coordinates and GPS sends guidance for the bombs. The pilot received a briefing emphasizing the importance of low-altitude flight tactics. Flying at 50-60 meters minimized detection by Russian S-300 and S-400 radars. The radar horizon, limited by Earth's curvature, reduced detection range to 25-30 kilometers. Pre-flight checks were completed at 14:57, ensuring the F-16 was mission-ready. Decoy UAVs were deployed to create false signals and clutter Russian radar systems. Surveillance drones monitored the bunker's activity, confirming the ongoing meeting inside. The F-16's flight path was charted through a clean corridor, avoiding debris risks. The pilot was trained to balance wing load and thrust during low-altitude maneuvers. The mission required precise timing to align with the bunker's operational rhythm. Ukrainian planners synchronized UAV decoys with the F-16's approach for maximum effect. The aircraft's systems were calibrated to handle vibrations from low-altitude flight. Engineers ensured the engine compressor could withstand potential foreign object ingestion. The F-16's takeoff at 15:03 marked the start of a high-stakes operation. The F-16 climbed briefly, then descended to 50-60 meters in a nap of the Earth profile. The pilot maintained strict altitude control to stay below the Russian radar horizon. Surveillance drones observed the bunker's antenna rotating, indicating active operations. Service doors opened and closed, signaling the presence of high-ranking officers inside. The F-16 navigated a pre-mapped corridor, guided by prior satellite imagery analysis. Decoy UAVs broadcast intermittent signals, creating confusion in Russian radar systems. At 15:18, the decoy package was fully activated to mask the F-16's approach. The ALR-56mm receiver detected initial radar paint from a northeastern Russian position. The pilot executed a beam maneuver, flying perpendicular to the radar's direction. The ALQ-31 system emitted broadband noise to disrupt Russian Doppler discrimination. A surface-to-air missile launch warning triggered, prompting immediate countermeasures. The pilot released the AL-50 tow decoy to divert the incoming missile. The missile chasing the decoy lost its target and failed at long range. The F-16 prepared for a critical pop-up climb to release the JDAM ER bombs. At 15:22, the aircraft ascended to 2,000 meters at a 35-40 degree angle. This climb energized the bomb's wing kits, extending their glide range significantly. The F-16's brief exposure above the radar horizon risked detection by Russian systems. The pilot relied on jamming and decoys to delay radar lock confirmation. The first JDAM ER bomb was released, targeting the bunker's ventilation shaft. The second bomb followed milliseconds later, ensuring a concentrated strike impact. The F-16 immediately dove back to 50-60 meters, entering the egress phase. Ukrainian drones confirmed the bomb's trajectory toward the target coordinates. The mission computer synchronized GPS corrections for precise bomb guidance. The F-16 evaded further radar tracking, disappearing into the low-altitude band. The pilot maintained radio silence, relying on pre-programmed mission protocols. The aircraft's radar signature was suppressed by terrain and electronic countermeasures. The F-16 landed on the mobile runway within 17 minutes of takeoff. Post-mission pod images were transferred to Ukrainian intelligence for analysis. The pilot broke radio silence only after safely returning to base. No electronic warfare systems were activated, as they were not needed. The first JDAM ER bomb struck the bunker's ventilation shaft at 15:27 precisely. Its delayed fuse detonated 1.1 seconds after impact, deep within the structure. The explosion compressed air inside, collapsing the bunker's pressure chambers. The second bomb hit seconds later, targeting the bunker's central gallery system. The shockwave shattered support columns, disabling the electrical infrastructure. The bunker's top plate caved in, burying corridors and equipment below. The high explosive power of the 454-kilogram bombs maximized internal destruction. The JDAM ER's wing kit allowed a standoff glide, reducing F-16 exposure. GPS and INS guidance ensured accuracy despite potential Russian jamming attempts. The bomb's delayed fuses were critical for penetrating the reinforced concrete. The ventilation shaft, a weak point, amplified the explosion's internal impact. The bunker's communication antennas, exposed on the surface, were obliterated. The internal corridors collapsed, trapping personnel and destroying consoles. The second explosion caused the ground floor to buckle under pressure. Furniture, tactical maps, and electronics were reduced to debris instantly. The bunker's three-level gallery system was rendered completely inoperable. The surface showed only a small hole, masking the devastation below. The bomb's precision ensured maximum disruption with minimal external damage. The JDAM ER's design prioritized internal collapse over surface destruction. The strike's efficiency demonstrated Ukraine's advanced targeting capabilities. The bomb's inertial guidance countered any potential GNSS jamming efforts. The mission computer maintained lock on the target throughout the glide. The pod imagery confirmed the bombs hit within meters of the target. The strike's success relied on weeks of Ukrainian signal and movement analysis. Satellite imagery had pinpointed the bunker's operational rhythm and vulnerabilities. The attack disrupted the Russian command structure at a critical moment. The F-16's pod data provided real-time verification of the strike's impact. The mission's precision highlighted the effectiveness of Ukraine's tactical evolution. The bomb's delayed fuses ensured the explosion occurred at optimal depth. The strike's shockwave incapacitated the bunker's ventilation and power systems. 25 Russian officers, including 2 colonels, were inside during the strike. The battalion commander and chief of staff were among the casualties reported. 3 ammunition officers and 2 level planners were also killed instantly. The first explosion scattered debris, delivering a shock to the occupants. The second bomb's impact collapsed the headquarters room, swallowing the lower level. The bunker's interior walls shattered under the intense pressure load. Support columns broke, causing the upper floors to crack and collapse. The electrical system failed, plunging the bunker into complete darkness. No fire occurred, but the pressure wave demolished the internal structure. Russian personnel had no time to evacuate as the facility imploded. The headquarters collapse signaled a major blow to Russian command. The strike halted forward position, planning for 8 hours on the front line. Artillery fire was delayed due to the loss of command authorization. Supply headquarters could not issue approvals, stalling logistics operations. Drone flight permits were suspended, grounding Russian reconnaissance efforts. Engineering activities ceased, leaving fortifications incomplete and vulnerable. Without orders, Russian troops remained inactive, awaiting new instructions. Relocation decisions were frozen, paralyzing Russian frontline mobility. The command center's loss created a domino effect across the Kersan front. Ukrainian forces exploited this gap, applying pressure on 8 fronts. The Russian backup headquarters was too distant to respond effectively. Manual data transfer extended coordination delays, worsening the chaos. Communication frequencies were disrupted, causing conflicting frontline orders. Some Russian batteries were unable to fire due to lack of targets. The F-16's single mission created a 72-hour operational standstill. The JDAM ER's penetrating warhead was designed for internal destruction, not surface damage. Its wing structure extended range, allowing safer standoff bomb releases. GPS-guided flight, backed by inertial systems, ensured precision under jamming. The delayed fuse maximized damage by detonating inside the bunker's volume. The explosion's pressure wave fragmented concrete, increasing personnel losses. Russian defenses, reliant on ventilation and power, were inherently vulnerable. Deeper shelters or thicker air defenses could not eliminate weak links. Ventilation shafts and surface connections remained exploitable targets. Ukraine's strike exploited precise geometry and timing for maximum effect. The mission's success required backup routes and jamming to counter failures. Bad wind or faulty fuse timing could have derailed the entire operation. Ukrainian planners mitigated risks with redundant targets and surveillance drones. The F-16's mobile runway ensured flexibility and reduced exposure risks. The aircraft's 20-minute mission demonstrated efficiency in high-stakes operations. Satellite imagery confirmed the central building's destruction in 14 frames. The blast depth of 3.2 meters matched the JDAM ER's fuse timing. Field reports verified the loss of 25 personnel, including key officers. The F-16's stealth and speed made post-strike tracking nearly impossible. Ukraine's pod systems provided critical post-mission strike verification. The mission's success reshaped Russian headquarters' discipline and operations. New Russian structures were moved deeper to avoid similar strikes. Decision-making processes slowed, reducing Russian frontline responsiveness. Russian officers reduced field visits, prioritizing concealment over coordination. Communication times increased, weakening Russian operational efficiency. The JDAM ER created a psychological fear effect among Russian forces. Ukraine standardized this mission model for future F-16 operations. Mobile bases were increased to enhance flexibility and reduce detection. Fuel supply lines were duplicated to ensure mission sustainability. Pod software updates improved targeting speed and data transfer rates. Pilot training was revised to focus on low-altitude tactical scenarios. Radar signature suppression was extended for better stealth capabilities. Ammunition fuse sensitivity was optimized for deeper penetration effects. GPS deviation was minimized, narrowing the accuracy range significantly. The F-16's mission structure became a blueprint for Ukraine's air strategy. A single bomb disrupted an entire battalion, showcasing tactical precision. Ukraine's strike broke the backbone of Russian command in Kersan.